How about that? Is that better? All right. So I'm Grant Williams. I'm a developer over at Sequoia Technologies. I just wanted to give a presentation about some different ways to visualize data today. So we can go ahead and jump right into it. And then I just want to confirm that. Ooh, hold on one second. So there it goes. All right. So let me launch this into slideshow real quick. So it should be ready. Sorry, one second. I accidentally closed it. Oops. I tried launching this in slideshow mode. That's all right. We can just do it this way. So we're just going to go over some basic plotting libraries in Python to start. So if anyone would like to join in the Jupyter Notebook, I'll post a link, and I guess the Twitch channel would be a good place. So I'll go ahead and post that over in Twitch. I'm so sorry. It's strange getting this launching. All right, so there is the link in Twitch for anyone who wants to follow along. And all right, so we're going to go over a couple libraries in Python today. We're going to go over the matplotlib library, the Seaborn library, which is an extension of matplotlib, and then a few of the statistics libraries that kind of allow you to do some more advanced visualization on top of that. And is there any chance I could get the audio muted for the microphone from you guys, just on the Slack call itself? It's a bit hard to hear. Okay, perfect. So that. All right. So okay, cool. And then, yep, that's perfect. Thank you so much. Sorry about that. All right. All right. And then let me make sure. All right. So succeed. All right. So the first thing we're going to go over is just some of these plots that are built into the matplotlib library. So you guys, oh, sorry about that. Looks like the link in the GitHub or in the Twitch was actually the wrong link. So let me send that over. All right, so there you go. So that has the Jupyter Notebook, so that anyone who wants to can follow along. So the first part of the notebook is just some imports that we're going to use across the Jupyter file. But so let's go ahead and jump right into it. So the Scatterplot is probably the most basic plot. It's pretty useful. So it just allows you to visualize individual events within a map. So in Matplotlib, you can do some neat things with it. So for example, you can take some random data, apply coloring to it. So you can apply coloring based on the magnitude of events, for example, which allows you to show some interesting things that we'll look at later. And then one thing that's quite helpful is you can actually scale these events as well. So as you can see here, you can take a scaling factor. So in this case, I just took a random scaling factor, and then you can apply that to the scales. And if you're going to scale them, then you can go ahead and apply the alpha command lets you change the opacity of the individual points to, and then this lets you see points that might be covered up by these new scaled events. So you can see down here that some of the events would otherwise be hidden if you don't scale them. So one interesting thing is because we're using Seaborn up here, Seaborn is a library that's built on top of matplotlib. It's kind of like a convenience library, and it provides a lot better aesthetic on some of these plots, but just by inputting the library, it will actually change the way the default plotting of matplotlib works. So you'll see that these look quite a bit different than they would normally look if you were using just straight matplotlib. And you can always change the default style back to matplotlib if you want, but I think that the aesthetic with these is actually quite nice. So you'll see that the color palette, for example, is softer. It kind of mimics, I think, the R library. So that is that. So one that I found to be very useful is the time series plot. So this is built into Seaborn. It's actually being removed soon. So if you want to use time series, you actually have to include this filter for the warning against the time series. They're removing it in a little bit. So you can still do it by hand, but at least for now, they let you use the time series plot with just a little bit of a warning. So I'm not sure how long it'll be included in the library. They might just leave it there for back and then just apply a warning for whenever you use it. But it's pretty useful. It shows kind of a deviation through time. So you can see that the primary points are plotted here. And then there's also the standard deviation applied along the lines as well. So this is quite useful if you have, if you're doing regressions or things like that, you can show through time some of the deviations in your data. And then, all right, so let's jump into some of the slightly more complicated plots. So this one is built into the Seaborn library. So it's not in matplotlib or pyplot. So it's a kernel density plot, and what it is it's basically an application of histograms, but it's smooth. So you get, so this is an example right here. So normally you would have, if you think of like a histogram plot, it would be a bunch of, kind of like a bar plot, just a bunch of different sized rectangles. And then you could draw a line over those. But the kernel density plot actually uses, in this case, a Gaussian kernel to try and better fit this data. And then there's a couple different things you can do with it. So this is just a shaded kernel density plot from Seaborn. But then we can look down here, and you can see the effect that changing the bandwidth of the density or the kernel has on the density plot. So the blue is the same plot that we have from up here, and it is the kind of baseline plot. And then you can look at how changing the bin size changes the way the plot is done. So if you, the most important part with using kernel density plot is actually trying to get a bandwidth that is accurate so that you don't overfit or underfit. So with the 1.0 bandwidth, we get a nice distribution across our normal data. With the bandwidth doubled, you can see that it actually over smooths it quite a bit, and you lose all granularity in the data, so it's not very useful. It just turns into basically like a straight Gaussian distribution. And then by reducing the bandwidth quite a bit, you can get some noise that's actually not present in the data as well. So it can really exaggerate some of the ways the data works, and then that can cause problems for you in statistical analysis. So KDEs are very useful. I would say the thing that I've used the most for has been to create heat maps of data. So if you take 2D, or you can take like an X and Y input data and then apply a KDE across it, and then you can plot that as a contour plot. So Seaborn actually has a built-in function, KDE plot, and it's the same one up here, but you can actually go ahead and pass it in two different variables, and it will make a shaded contour plot for you. So this is, you could think of some pretty useful things to this. Like, for example, if you want to show a population of people on a map, then this KDE plot with the heat map might be actually a fantastic choice. So, and we'll look into some examples of how to use some of this stuff in a minute. And then building on top of that, we can actually do a contour plot from Seaborn. So this one is basically just an extension of the KDE plot. So it allows you to either do a contour or a KDE, and then we can see the distributions on the sides as well. So you can see the nice X distribution right here and the Y down below. And then I went ahead and put on some scatter points here as well. It just made them rather hard to see. So you can see what the data looks like itself. And then you can see the plot from the contours that shows the density of these data points, and then the X and Y different densities. So these are on the same kind of distribution, so it's not too surprising that they look the same. So that was the contour version, and then you can look down here and you can see that it's just as easy. Seaborn allows you to pick what kind of plot you would like. So just by simply changing, if you want to go from a contour to a KDE, you can just change right here the kind and make it a KDE, and it allows you to really easily make one of these distributions. And you'll see that when you do that, instead of having these histograms for the distributions for each individual axis, that it actually converts those into KDEs as well. So these can be a great way to, in a business setting, kind of show the distribution of your data, and it breaks it down to you by data point as well, which is quite nice. And so the only thing that you have to do is you have to pick a statistical distribution. So it will automatically try and pick one for you, though. So you can see here that I have my stats data right there. And so if another way to visualize the same kind of data is you can use a hex plot, which is the very same idea. The only difference is instead of a discrete function, we get these nice hex patterns that can sometimes show a little more granularity in the data just by allowing you to see kind of a bigger difference between neighboring points. So the hex point or the hex plot is actually quite good. You can use it kind of in the same way you would do with a KDE with scatter points over it. So it kind of allows just in one plot to have a nice combination. But you'll see that the points are discrete, so they're not smooth like they are in the KDE. So it's the same way here that you don't have this, you have the histogram instead of the KDE on the sides as well. All right, so we're going to go ahead and jump into the 3D parts of plotting. So this is, so to build a 3D plot, you will actually need this part of the library right here. So the MPL toolkits. So it's an extension of Matplotlib, and it just allows you to build different 3D plots using the same base tools that Matplotlib applies. And you can see that the Seaborn plotting style is actually applied to these as well. So that'll be continuous throughout. That will have the nice aesthetics from Seaborn applied throughout. So yeah, this just allows you to build a 3D project or a 3D graph. So the first thing you want to do is you want to make the empty plot frame. And then on top of that, we can start to build some functionality. So probably the simplest plot you could do would just be a line plot. So that still works in 3D. So here, oh, sorry about that, Java update. So here's a 3D line plot. This is a parametric plot. So I think the easiest way to do the 3D plotting, I don't actually know, I'm not positive if you can do it in other coordinate systems, but you can use parametric plotting to do it very easily. It might support other like spherical coordinates as well, and cylindrical, I'm not quite sure actually. But so you can see here that you just define your X and Y in the parametric coordinate system, and then you can plot it really easily, and it gives you this beautiful little 3D line plot. And then you can actually use these line plots to make some more advanced shapes as well. So the way you would make a line plot, actually, you can't just use the line plot method that we used earlier. But one thing that we can do is we can actually use a 3D scatter plot and then just make enough data points so that we can sample it into a 3D shape. So if you see here, it looks like a continuous line plot, but it's actually just a bunch of scatter points. And if you want to do some visualization with these, you can actually apply a color map. So you can see here I've taken the color map from matplotlib and I've applied it to the z value. So it's just important to know that you need to normalize the color map. So you can take the max value of your z-axis and then apply the color map along that. And that allows you to get this nice colored spring right here. And then continuing on that, with way less data points, it's pretty easy to just make a nice little scatter plot that you would expect from just a normal scatter plot right here. So and the same thing, if you want to color it, you got to make sure to normalize the color map across the z data or the z-axis, and you'll get a nice colored scatter line plot right here. So there are some pretty nice 3D plots for looking at more advanced functions in matplotlib. So one of them is the wireframe. So what you need to do is you take your x and y, and then you need to combine those into a mesh grid. So it's a little more complicated than just plotting x versus y versus z. So you take a mesh grid, and then you can apply a value function on top of that. So in this case, I'm taking the function from the logo of the MATLAB programming language, which is kind of a famous little plot. And then you apply that across the mesh grid, and then you can easily plot this with just a wireframe plot. So it looks quite good, you can see here. And if you want to color this, actually matplotlib does not allow you to do a colored wireframe plot. So the way you get around that actually is you have to do a surface plot. So it's the same idea. So you would take the, sorry about that. I don't know if you guys can hear that. I think they're testing the tornado sirens here. So hopefully it's not too loud for you guys. But so you would actually, if you want to do a colored wireframe plot, you actually have to do a surface plot, which we'll go over first. So the surface plot is kind of like the wireframe, but it's actually just continuous across. So they're quite easy. So they're all set up the exact same way. So you make the mesh grid, and then you evaluate across the mesh grid. Then you're able to plot those quite easily. So if you want to normalize these, the normalization is a little more complicated. You have to make sure to normalize across the max and the min instead of just the max on these. And then you can shade it, set to true, and it will plot this beautiful function right here. So if you want to make a colored wireframe, we actually can't just apply a CMap like you would, or face color or anything like that, to the wireframe. So the way you get around that actually is by doing a surface plot, doing the coloring, and then you set the shading here to false. And then you can actually turn the face color to clear. And then so that allows you to see through the face colors, and it actually gives you this nice wireframe looking plot. So if you do need a colored wireframe, you can get by doing that. So although usually I would say that the surface plot shows you a little more information. So all right, so let's get into some of the more fun parts of using a Jupyter notebook, for example. So this program I'm using is called Jupyter, and it allows you to make these interactive notebooks that you see I'm using right now. So, oops. All right, let me make sure that this is launched up here. There we go. Got to run my endpoints. Sorry about that. So Jupyter actually has some built-in functions right here. You can see from the Widgets library. So these actually allow you to make some really interesting things. So I just have a simple line plot here with a slope and a y offset, right? So these interactive widgets you can do actually allow you to change the data dynamically in your plot. So it's a little choppy when you do it, but I think it makes it for if you're doing some exploratory work, say in machine learning, and you want to try some different inputs, it gives you a really interesting way to just kind of browse through some of these. So you can see this is an offset as well. So it's quite easy to use. It's very intuitive. It's built right into Jupyter, so it doesn't require any external libraries. When you use Jupyter Notebook, it actually comes with this widget library. So there's some really interesting things you can do with that. And then, all right, so let's talk about inputting animations into Jupyter. So there's actually quite a few different techniques you can go through that allow you to embed these animations. So one way is to use the animation sublibrary in Matplotlib, and then you can use the display part of Jupyter Notebook to embed it as an HTML element. So this is just an initialization. We can set up this empty grid here, which will be a line plot, and we can just set that value, the x and y values to an empty array and get this nice empty function up here. And if you look down here, you can see that we can make a function here that just once again sets the data empty to these empty arrays and returns the line. And then we need a animation function here that takes the same line data and we set with a new updated x and y value. So it looks like it's a little choppy on Twitch. It might just be because of the frame rate on the Slack call. But if you do this on like the Jupyter Notebook linked, for example, then it should be quite smooth. So basically, we're just using the animation function that Matplotlib has. And then you set a number of frames and an interval, and then you can embed it into an HTML5 video. So you can see it's looping right here as an HTML video, and it will look quite smooth. And then blitting here just means that you don't rewrite data that doesn't need to be rewritten. So if you have parts of the frame that are the same as the last plot, then we don't need to update that. So that'll just make it run a little smoother. And then the other way to look at data is you can, for example, if you have a source video that is local, so you can actually import that. So here I have, I wrote just a little traveling salesman problem solver, and then I exported the solution to a video using a different movie library. And then you can actually just load that straight in and run that. And so you can set things like controls and autoplay. So it plays quite nice with HTML. You can also use JavaScript to embed these movies. So these Jupyter notebooks are very flexible. So you can see here, it's going through these iterations, trying to find the shortest path. And this is the cities in the current path. And then over here is the current shortest distance. So you can see it pretty easily that this is quite an easy way to embed a local video. The downside is I wouldn't really recommend using this if you were going to embed videos. I think generating it in the actual Jupyter notebook is quite a bit easier, but this is definitely an option. So then, all right, so let's talk about some of the statistics plotting that you can do that are built into the Seaborn library itself. So probably the most common one I've seen is the box plot. So if you've ever taken a statistics class, you are probably quite familiar with these. So they are quite useful. So C1 actually has some nice data sets built into the library. So this one is an example data set that has tips broken down by male, female, day of the week, and then as a property of the total bill as well. So so you can set up these box plots to be split on the sex. So we have here, so we change the hue, and then that allows us to split based on sex. So we can see these nice side-by-side plots of male versus female on tips on day. And then, so they include error bars, and then I believe these are what, like the 95th percentile on box plots. And then, so that is quite nice. And then, and the same kind of example would be a violin plot. So these are very similar to box plot, but instead of using error bars, these actually use kernel density estimates. So you can see that this is the density from the KDE. This is the this would be basically your box plot, while the whole outside would be like the error bar, and then your median value is the white dot, or in the box plot, it's the line. And then this is the, I think, the 95th percentile on the inner line for the box plot. So it's just another way to visualize kind of the same data. So you can look on which one makes more sense for you. So I personally kind of like the Violin plot more. I think you get a lot of information out of the KDE. So you can see, if there's any outliers just by if there's a spike in the density of a certain point compared to the overall length or anything like that. So I think it provides a more interesting representation. For example, this Friday, even though it looks like the males got more tips, you can see that there's some pretty big outlier up here. So that has a pretty big effect on it. So, and then on top of that, you can include a swarm plot here. So swarm plot is kind of like a scatter plot mixed with a box plot. So it's a way to look at the values put next to each other. So you can see it's split between male is blue and female is green. And then you can see that these are the individual data points along with the violin plot. So you can apply this really easily. So you can just plot on top. It's the exact same thing right here, swarm plot. And you can actually apply this to the box plot as well if you'd like. So it's just a really simple way to kind of check your distributions and make sure that they kind of make sense and that you don't have any crazy outliers that are ruining the rest of your distribution. And so you can actually use some really interesting plotting built into some of these other Python libraries. So for example, this is the natural language processing library. So it's it's a Python library that has some interesting built-in functions. So in this example, I'm reading in the a King James version of the Bible as a text file, and then it will automatically tokenize the file for us. Then we can strip things like punctuation, and then it will plot a distribution plot for us that shows the most common words. So right now I didn't do any kind of search on different kinds of words used. So, or I didn't do any kind of limitations. So, obviously the most common words are like the, and, of, etc. But you could apply like a dictionary values that you want to accept and ones that you don't, and then this would allow you to easily be, to show a nice distribution without having to do any of the work yourself. So it's just an example. All right, so let's do one really fun example. So I took this off of the Kaggle dataset. So it is, so I don't know if you guys are familiar with the game Pubg, but it got quite popular for a while. It's a battle royale game. So the way it works is, here, let me see if I can pull up a map of it. So so the way it works is everyone drops in on a island, and then you have to take this. You have to fight your way until you're the last ones surviving. So there's different points on the map where you can fall that have more supplies and stuff for you, and it allows you to you can kind of go for higher risk, higher reward areas to get better supplies. So we're going to take some data off of Kaggle actually and use a heat map to look at where the most common places that people die in the game. So first you can visit this link right here. It has the data from and then a lot of this code explanation as well. So let's go ahead and just jump straight to the end. So so this is the map of the game, and then you can see these areas that are in red are areas where people die most commonly. And then you can see that they are at these towns and stuff. So these towns have much better loot than other areas. So you can kind of see a breakdown of what drives the game. And this is an aggregate across, I think a couple hundred games. So another interesting analysis that would have been really fun to do would be to look at how it changes through time. But I did not have enough time to finish that up. So maybe at some point I can push an addendum to this that would have the heat map changing through time. I think that would be quite neat. So you can actually pull this off the Kaggle website yourself. So it has a nice CSV file here. You're going to need pandas, which is a library that allows you to kind of pull data into these things called data frames. They're kind of like it's kind of like using SQL. It's quite similar actually. So we can pull our data from the TSV files that we have provided from Kaggle. And then you can, so basically what you're doing, it also provides a nice image of the map. So you're going to want to take that image and resize it to the value you want. And then we're going to make a 2D histogram here, and then apply a Gaussian filter on top of that. Another option would be to do a KDE, which is what I was originally going to do, but because there's so much data, the KDE was actually so slow that I wasn't finishing. I read it on for like 20 minutes and it was not finishing. So it might just be too much data. So these histograms are much easier to compute, and then applying a Gaussian filter on top of that is quite easy. So, but it gets a very similar result because the whole point of the KDE is to apply a Gaussian kernel across bins. So, so we're kind of making our own Gaussian or our own KDE here. So you can take the image from the Kaggle set and then calculate these heat maps, and then apply a color scheme to it. So I just did a hot color scheme, yellow to red, and then set the opacity to half again right here. And then you can apply that on top of the map, and you get this nice visualization of the most dangerous areas in the game. So it's quite a fun example of how to use data. So, and all right, so that is all I had time to prepare for the talk today. So I guess I would be happy to answer any questions or anything like that.